Hi, my name is Neill. I'm with Advanced Print Electronic Solutions. So I'm going to talk today about a bunch of application use case studies to kind of mostly motivate and illustrate, the types of things that, you can do with additive based methods. So, what you're seeing here in the show here is a range of different technologies, inkjet, some of these other tool types that deal with, various capabilities. But I'm going to be focusing on really, kind of the additive based approach where we're mixing various tools with the platform that allow you to build up stuff in a kind of interesting way. So I'm just going to go through a quick intro in kind of define baseline everybody, talk about a few case studies, and just kind of wrap it up. See some demos along the way. Quick, my company, I already told you what we do. We're focused on the AME side of the business. I'm the founder of the company. Our primary business area is really in AME engineering. Okay. I'm sorry? Okay, but they can hear me, right? Okay. Really to, focus on AMA engineering and system solutions, really customer driven in terms of application development. We really handle prototype through pilot manufacturing and then hand it off to either the company that we're working with, or we can work with our partner to deal with, larger volumes. We have a robust technology and R&D program, and we're based in New York. Okay, so what is my company focusing in, and what is the area that we're going to talk about today? So, additive manufactured electronics, for the purposes of this talk, is really the application of printed interconnection features and or components on either on the surface of some substrate or within some substrate in three-dimensional space. Some of the benefits, is the ability to build an integrated product, much more flexible form factors, because now you can start doing things in 3D geometries. You're not limited to planar structures only. It does provide the opportunity to do miniaturization, new functionality from a product development perspective. It does really give you benefits in terms of the option and capability to reduce the component counts. Basically, there's efficiencies that are gained, and also from a sustainability strategic perspective, additive processes are cleaner than most subtractive processes, and it does give you the ability to kind of reduce your carbon footprint and so forth. Quick landscape. This is not a exhaustive list. These are some of the companies that we're working with and that we see, rising in terms of some of the products they have available. But these are, platform manufacturers. There's obviously new ones coming all the time, and this list will be updated. But these are the companies that we're most familiar with. Some of the folks that are at the show here, like XTPL, Corona, Humic, IDS, they've been around for a while, and they offer some really advanced capabilities that are interesting today. So I just wanted to throw them up, all these up here, so you guys had a list of sort of the players in the AME space that we're working with and would worth talking to. From a conformal and space, we're going to talk about a few apps. So the first one is one that we're kind of working with specifically. This is for a drone. It's an expansion platform that allows you to minimize the size of the drone in terms of its overall height, reduce the weight of the product, and it is used for a confined space application. And this kind of just shows you like how you can have a conformal substrate. In this case is a quadcopter, and utilize basically build a backplane on it, reduces the number of components and such, and it's just example number one. Example number two, this is something that Nscript was working on. This is showing you the application of really components, embedded electronics, interconnects on a cylindrical structure. This is a specialized sensor application. And again, this is just to give you some of the view of like how you could work in really different types of shapes, different complex geometries, and so forth. This is part of a European project, a consortium called Ampere. Basically, the goal here is to develop a new type of pacemaker extraction tool that I didn't know this, that I didn't realize that pacemakers, when the electrodes, like, they need to be replaced, that the electrodes are like get embedded within all the tissue around the heart area and such. So like removing them today is kind of like a risky job. So you don't want to get a pacemaker removed. You don't have